Hey, look up.
Is it recording us right now?
It is.
Oh.
Hence the flashing indicator there. So
We could make this a very memorable
one of the, I thought it was funny. One of the funniest things that I've had happen with the recordings is I have a habit of when I need you all to focus on the discussion that I will whistle. Like you've seen, like that, you know. Listen. So I had a student one time who was watching a video at home, and she's like, "Mr. Smith, it's the coolest thing ever. I'm like working on my homework and watching the video, trying to remember some things, and you whistled, and my dog came running." So, okay, look here. Let's go here to the main board. Okay, just got a question. It's very common. You need to talk about it until you're really comfortable with it. Listen close. I'm trying to get all of you to break a habit. Okay, most people, when they come to calculus, they have a habit of just copying what the teacher did. And so they're like, well, in this kind of a problem, I move things like this. And in this kind of a problem, I move things like this. But they're not paying attention to any rules whatsoever. You got to get away from that. It's all about following a rule. So for example, the question I just heard was this one. You have 1 over negative x to the negative 4. Did I copy that right? Okay. That doesn't change, that doesn't move, but there is a rule that will allow you to do something here. Here's the rule you must memorize. The rule is, if you have 1 over any base to any exponent, that's exactly the same as same base to negative 1 multiplied by the exponent. So I'm going to apply that rule here. I'm not going to move anything. I'm going to apply the rule. The negative 1 is not part of the x. The negative 1 is a multiplier. So what this really is 1 divided by negative 1, and then 1 multiplied by 1 over x raised to the negative 4. Well, that's just negative 1. And this, using the rule, would become x, negative 1 multiplied by negative 4. And so I ultimately end up with negative 1 multiplied by x to the positive 4. Now I do it all in my head. I don't have to write anything down, but that's what I'm thinking. Does that make sense? Okay. Yeah, you got to get away from like things move. Nothing moves. Like you apply a rule and then it changes.
Is the test for this like comprehensive? Like, does it have stuff on last?
Oh, really good question, Ellie. No. So test 2 is just what we've been practicing. So test 2 is simply, it's 25 questions, and every single question is of exactly the same format. In fact, if you look at this green packet that I passed out, it says day 2.6. This has 25 questions, just like the test. This has, every question is multiple choice, just like the test. Every question is basically, start with an XY formula, use the derivative rules to then create a y prime formula, or dy dx formula. Does that answer your question?
Yes.
Test 3 is comprehensive, and we'll practice for that as well. So test 3 will cover all of first semester. So, okay. Anybody else? Okay. Next thing. Another comment that I heard as I was passing out packets is it can be a struggle getting all of this memorized. So I want to do something this morning to show you what I would recommend you do on test day. So next Friday, here's my recommendation. You come into the room, you find your seat. The seats will all be rearranged again. And then when I say, and the first thing you ask for is a piece of scratch paper. You put everything away, because you can't have anything out. But before you start the test, I would write down on the scratch paper a kind of compact form of most of the rules. I don't write all of them because I don't need to write the add subtract rule. I can remember that. But I would write other rules on this piece of scratch paper. Like, for example, I would write, let's clear this off. Before I start the test, I would write, if I have the derivative of something to a number, I know I'm going to rewrite that as the number multiplied by the something, n minus 1, then multiplied by the derivative of the something. And before I start the test, I would just make a list. If I have the derivative of e to the something, that's going to be rewritten as, let's see, e to the something multiplied by derivative of the something. If I do that before I start testing, then when I'm testing, my brain it doesn't have to remember anything. It can just look at my sheet. Like, I think that's a really good test strategy to help you score higher. So I have a few more packets to pass out. I would recommend you take a moment and just turn this over and just see, like, how far can you get in trying to remember rules. If you can't remember any of them, what I would do is I would glance at this, turn it back over, try again. Like, you can't just copy it. Like, you could write this over and over again 100 times, and maybe by then you'd have it memorized, but it's not a very efficient approach. Much more efficient to look at it, turn it over, see if you can write it. So go. I have some more packets to pass out. I'll explain it. They don't work on any packets yet. We're going to work together today. So don't work on any packets yet. We're back to recordings. Okay, Luke asked a good question. You do need to be prepared for it. There will be at least one inverse sine or inverse cosine question. It's not going to be a lot because it's not a heavily tested thing, but you do have to have the formula memorized, or you will miss that question. So you've got to have, the only formulas you don't have to have memorized are the two at the very bottom and the chain rule formula. Those three will not be tested. Everything else is tested, at least once.
We need to know the two at the bottom for
You will. We just don't need them quite yet. So the chain rule and the inverse rule, we'll practice those for test 3. And then the last one, which is the derivative of an integral, we'll use that like in February. The derivative of an integral looks terrible on paper. When you actually use it in a problem, it's one of the easiest rules on the entire sheet. It really is not hard at all. Okay. Okay, so you now have the full rainbow of colors available at the Copy Center. They're all labeled. So day 2.6 is the first one. That's the green. Okay, day 2.6, this green packet is a practice test. You'll do this at home. If you go to Canvas, there are instructions as to what you should do. Okay? So this you do at home, we're not doing it here. I expect that you'll have it done by the time I see you on Monday. The green practice test. Next in the list is the purple practice test. It's labeled day 2.7. Same thing, instructions in Canvas for what you should do. I'll expect that this is done by Wednesday of next week.
Would you recommend that we memorize like all the rules completely before we take these?
Listen to Carter, everyone. Really, the best way to succeed on the test is to do exactly what he said. Like, you get these memorized, and then you do what we just practiced. You say, okay, I'm going to practice my test now. You put that away, you take out a piece of scratch paper, you quickly write down all the rules, and then you go to work. Yep, that's the best way. It's simple. The best way to succeed at anything is to practice what you're going to do. Like, the closer you can make practice to real experience, the better you'll perform. Athletes do that all the time. Heard a really good story. Look up. It's a good one. I don't know, anybody play baseball? Softball, yeah, similar thing. So, you relate to this. The story I read was of a coach who who traditionally, when they did batting practice, they would do like, I don't know, like 10 fastballs, 10 curveballs, softball, rise ball, whatever, right? Is that fair? Okay, the coach tried something different. He said, I need to make this more like a game. And in a game situation, the batter does not know what pitch is coming. So they changed batting practice to be more like a game simulation, where the batter wouldn't know what pitch was coming. He said the players initially hated it because they were so accustomed to, okay, batting practice, just, kind of get in the groove. But he charted the difference. Like he paid attention to their batting average when they did one style of batting practice versus the other, and it went up because it was more like a game situation. I try to do the exact same thing as much as I can. That's why I give you a lot of packets, where instead of like a sheet where every single problem is the same, it's like an assortment. So you get a better feel of like what a test is going to feel like. So same thing when you're practicing for a test, you want to practice as though it is the test. You'll see the instructions in Canvas say that in those same words. So, questions? Cool. Next one. Okay, so that was the purple. Then you have 4 packets. The other 4 packets are labeled 3.1, 3.2, 3.3, and 3.4. These are the first 4 packets for Unit 3. Okay? Here's what we're going to do. We have got to stay on track for May 9th. But I also want to make sure you're well prepared for Test 2. So we're going to kind of accomplish 2 things simultaneously. We're going to get a really big head start on Unit 3 while we prepare for Test 2. Because many of the problems in these 4 packets are really good practice for Test 2. Plus, you'll then have them done by the time we merge to Unit 3. So we'll be ahead in Unit 3 as well, so we can stay on track for May 9th. So at home, you're doing the purple and the green, as it says in Canvas. In class, we will be working on the other 4. We won't be doing every problem, but we'll be doing selected problems to help us practice for Test 2, plus get a head start for Unit 3. Does anyone have a question about any of that? Okay, so here's what you want to do now. You want to get a page in your notebook, because you won't do the work here. You want to label that page as buff number 1. Because we're going to do buff packet number 1, or you can put day 3.1 number 1 if you want. It helps if I didn't steal. Yeah, sorry. Taking her packets. So you're going to write buff packet number 1. And what you're going to write is just this formula right here. Okay, so write buff number 1. Ollie's doing it perfectly. And then you simply write this formula. So today, and Monday and Wednesday, this is what we're doing. You're doing the practice test at home, but in class, we are practicing for the test using these other packets. Okay, notice, you can see it in the buff. It says, if you have this formula, then the value of dy dx. So if I have this formula and I'm supposed to find dy dx, that's what we've been practicing. Start with a formula, use the green rules to find dy dx. So that's what you're going to do. So go. This is like a good simulation of a test question. It's exactly what you'll encounter next Friday. So go. If you have a question as I walk by, stop me. Okay. Please raise your hand if you have the red written on your paper. Who has the red written down? If you have the red, give yourself 4 points. On the test next Friday, the red will not be an answer. The multiple choice answer will be the yellow. So you have to remember the factor. Okay, question? Questions on any of it? This is all we're doing today, Monday, Wednesday, just practicing problems you haven't seen before to prepare you for the test. Please. We won't for this unit, so that will be unit 3. It's only a couple more steps, so that's why I also want you to make sure that you keep a record of this, because in unit 3 you'll have to submit the buff packet, it's a quiz, and this way you've already got most of the problem finished. So like in Allie's work here, she'll easily be able to do over here what's necessary to finish the problem. And we'll cover that in unit 3. Questions? Anything else? Okay, next thing. So now we're going to go to number 2. Now number 2 is a question that could show up on the test. Like you can do all of that. So don't. Like you can get a multiple choice answer. So good work. Just stop me if you want to ask about anything. Yeah, like when you look up here, Luke asked a good question. I say it all the time. The A/B test writers always find a way to make it look different. What you see there is no different than if I had written this. What you're more accustomed to is we start with an equation like y equals natural log e raised to the 2x. Come on. You dumb board. Hold on. So we start with So we start with y equals natural log e raised to the 2x. It's not going to work. And then what we end up doing is we take this side, we apply a d operator divided by a dx. We do the same thing here. That's exactly the same as this. No difference. Is that your question, Luke? Yeah, this one you can give me a multiple choice vote. So you give me the multiple choice answer, or you do this if you don't know, but you have to vote. So show me the multiple choice answer, or a fist if you don't know. So show me the multiple choice answer, or show me a fist if you don't know. If you're doing this, give yourself this many points. Questions from anyone about anything? Please.
So don't you just look at this and see that natural log and e are, I don't know what the right word is, but they're like inverse of each other, right?
They are.
And so that just leaves you with the direct and then
That is totally valid. Here's what Megan is remembering. The natural log of e to any exponent is simply the same thing as just the exponent itself, because the natural log and the e function are inverse functions of each other. So you can start the problem by saying this derivative, that's just the same thing as d of 2x. And I know that d of 2x is simply 2. Yeah, that's totally
So
fine.
it's okay to not.
Oh, yeah. Good point. Either way. Other questions? Okay, keep going. Practice for the test. So, number 3, it says the slope of a line tangent to this graph. Well, we know that we can find the slope of a line tangent to a graph if we can find this formula, because this is a formula for computing the slope of a line tangent to the graph of that formula. So this is just a different way of saying, please go find dy dx. And then once you find the formula for dy dx, just plug in an x value of e squared. So you can do this one, go. I'm also real good. All right, here we go. Show me your vote. Show me your vote.
Hey, I got the same answer.
So give me a vote, or give me a, I don't know. If you're doing this, give yourself this.
I like how
Anyone have any questions? So on the test you take next Friday, the question will stop at the red. It won't go further. This again is a Unit 3 question. But as I said earlier, you know, the first part of Unit 3 is not like a lot more than Unit 2. So 2 points per second. Anybody else? Okay, so again, you now have done basically 3 problems from the buff packet. Make sure you have them well labeled so that when we get to the buff packet, you can just say you've done them. You don't have to do them again. So, here we go. Next thing. Okay, so same idea. They give you a formula for f. You are supposed to find a formula for f prime. And then once you have the formula for f prime, you're supposed to find what that formula's value will be when the x-coordinate is 1. Go.
And that translates into 1/2 formula.
So this is the formula for f prime at any x-coordinate. They would like us to find the value of f prime when the x value is 1. So we literally replace the x with 1. 1 plus 1 would be 2. 2 squared would be 4. 2 divided by 4 is the same as 1/2. So. 2 points? Please, Alex.
Can you explain like how you would read that question and know to just
Know to do. So it goes back to, let's see. Goes back to Unit 1. You have a formula f. That's a formula for finding a list of x, y values. Then it says don't let x equal -1, which is, and that makes sense because if x is -1, I have 0 on the bottom, which means I don't have anything. So skip that. It says f prime of 1. That means what I have to start with is I've got to go find the formula for f prime, which means I've got to use the green derivative shortcuts to find the formula for f prime. So I did. Once I have the formula for f prime, I'm simply supposed to plug in an x value of 1. Please.
Is the clue x does not equal -1? Is that just kind of a throw us off? Like
It's a clue that, to be fair, most math classes you've ever had would never have said that.
Yeah.
They would have just kind of assumed you knew it.
So it's just there.
It's just kind of there. The AP test writers are just making sure you understand that this formula is not valid when x is -1. That's all. But you're right, they throw it in just to kind of give more things for your brain to kind of get distracted by. It's very common. So. Good point. Okay, next thing. Okay, number 5. Number 5, you can solve. It's just like a test question. One huge hint. Previous to this class, you would have learned that the cosine squared of something means this in purple. It means the cosine of 3x is being squared. So you should start this problem with the purple. That's where you start, right here. If it were cosine cubed, then this would be cubed. Go. This is exactly like what you can expect next Friday. So, hold on, Jay. Okay, show me your vote. Oh. Show me a vote or show me you don't know. So. If you're doing this, give yourself this. Questions?
Three up here and then 6.
All right, next thing. Okay, you were supposed to have learned in a previous class that arc sine and inverse sine are the same thing. So if you didn't, no big deal, just memorize it now. So arc sine, inverse sine, same thing. Go. These are all old AP questions, so these are good examples of what you'll see on the test next Friday. Okay, show me your vote. Show me your vote. Show me I don't know. Keep going for it. Hands up. Work one.
It's like a good thing. Like illusions are like super nice past and you can like soup. Have you ever souped before? Because like it gives you like instant help. So you can like,
Hey, show me your vote.
you know, like,
Oh, it's been too long. I remember now.
That's funny. If you're doing this,
I meant to.
give yourself this. Questions? I didn't write this one out, but you need to see it. You need to see it wave at me. Waving. Okay, cool. Next thing. Go. That was just luck. Yeah, don't find it. These turned out that way. These are all Unit 3 questions. I'm just going through and making sure we don't hit something that we haven't talked about yet. What's that?
The entire time.
I got this.
It's training your brain.
What are you bringing X over? X over X is 1. So 1
I actually like factoring. I don't know how to feel. I don't know if I should be a fan. I'm just gonna go straight to it. Hey, you know what? Honestly, I like.
The original here would get E before I showed you. Yeah, I was able to get E before I showed you. Give yourself 10 points. You would want to talk about it.
So like on the green, when it becomes 1 over x, that's because the gx changes, right?
Yeah, the first time I used the ln rule, so from here to here, I'm using the ln rule, but the g of x in my first use of the ln rule would be ln of x. And then when I go from purple to green, I'm using the ln rule again, but now the g of x in the ln rule is just the x. Cool, let's keep going. Go. And these are all in your buck packet. You can either look at the board, look at the packet, whichever's easier. So. Okay, show me your vote. Oh, waiting, still waiting. Keep going. Do you play?
It's actually not that hard. I got my out to the left, so.
I was really bad. Like, I tried to play baseball too. No one showed me what to do. And that was the problem. No one taught me. But I tried to get that. And I did okay, but when I first started, no wow. When I first started, don't even just play it. I was okay.
That's just because.
Is that like good? What do you like things to do with music?
So I do create machines. Like I get in there, I hit where to try, and then I get it.
That's where my brain is.
Yeah, it's extremely. I was like, maybe my coach just said she takes some of this
I actually love getting copies of this.
I didn't get hurt. But I learned that, like,
Yeah, I thought that's what you did.
Chances are they did it, but there's like a chance. But like chances are.
I never got that. Okay, show me your vote. Show me your vote. If you're doing this, give yourself this. Yeah. Questions? Please.
I don't understand how we divided that in this term.
Hold on. Let's keep talking. So you're okay that to find the derivative of this, I must use the quotient rule.
Yeah.
So I've got to take the entire bottom, and that's why I put the 4 plus x squared in parentheses. And that must multiply by the d dx of the top. But d dx of 3 is going to be 0. So this entire set of parentheses multiplied by 0 will be 0. Then I say minus the top, which is 3, to the top, multiplied by the d dx of the bottom. That's this. There. So I've got 0
Wait a second.
minus 3, and then d dx of this is just 2x.
I'm just confused because I always thought it was just one number that the derivative is 1.
No.
But then I feel like in every other problem we've done this whole unit, it would have turned out as 0.
No, what's different? Here's probably what happened. Okay, look here. See this. I think I know your mental wrestle here. This is d of 3 dx all by itself, and that's equal to 0. And then 0 multiplied by whatever would be 0. What I think you're remembering is the following. This one here, d of 4 plus x squared, that's the same thing as d of 4 over the x plus d of x squared.
So it's 0 plus 2.
So now this is still 0, but you're adding it to something, so it seems like it disappeared. Where here, this is still 0, but you're multiplying. See the difference? Does that help? Okay. Anybody else? Cool, keep going. More practice. Okay, look. This is identical to one that happened earlier. They're giving you a formula, and it says find the slope of a line tangent, which means find the derivative when x is 4. So you can do that one. Go.
It's true, I'm not gonna lie.
Oh, I gotta show everyone a shortcut here so we don't get so gross.
Yay.
Look at the board. Look at the board. I think this is what Holly's referring to. Okay, raise your hand if you're able to get that far. Yeah, 2 points.
Yay.
Okay, here's something people don't often think of, but it is a highly valuable shortcut. Raise your hand if you can tell me. Now, I keep emphasizing you shouldn't just move things around. You should understand why things are the same. That's all we're ever doing is finding things that are the same. So this is x divided by 2. Raise your hand, please. What's another way of writing x divided by 2? Same thing, just different. Like what's another way to write x divided by 2? There we go. Don't overthink it. It's very simple. It's really simple. Just people forget. Jay, what is it?
1/2 times x, or
How-
just 1/2 x.
How many knew that 1/2 times x is the same thing as x divided by 2? 2 points, 3 for Jay. So what I'm going to do is think of this. I'm not going to write it. Just think of it as 1/2 times x. Raise your hand. What is the derivative of 1/2 multiplied by x? Hands up. I want more hands, so let me give a hint. Raise your hand if you know the derivative of 3 times x. Raise your hand. What's the derivative of 3? That's better. What's the derivative of 3x? Don't overthink it, Adelie. Raise your hand if you knew that was 3. 3 points. So raise your hand. What's the derivative of 1/2 x? Come on. Let's go, Holly, in the back. How many knew? 2 points, 3 for Holly. So finish the oh, sorry, I gotta keep talking. So the purple here is just 1/2. That's it, just 1/2. The other item that people often forget, you learned quite a while ago, is when you have a fraction divided by a fraction, it's the same thing as the top fraction multiplied by the reciprocal of the bottom fraction. Way.
Wait, this is
Yeah, dividing fractions is as easy as pie. Just split the bottom and multiply it. Yeah. James?
Wait, could you just plug 1 for x? So then it would just be 1/2.
Now you, hey, listen, hey. Look, don't ever plug in x equal 4 until you've finished using all the derivative rules. Otherwise, you will get the wrong answer. But now we have finished using the derivative rules. We need to practice for the test you'll take next Friday. So you have in front of you here 3 factors. Therefore, you are allowed to combine the factors any way you choose. I can see that 2 over x multiplied by 1 over 2 is simply going to be 1 over x. So on your test, this would be the answer. On this test, they would then replace the x with a 4, making B the correct answer. Sydney, please.
You know, I probably did it way harder, but we changed it to 2x to the negative.
You gotta be careful. You can change it to be ln of, this is legal.
Well, we did the ln rule, and then we changed it to
Oh, this.
X. We changed it to, instead of a fraction, we changed it to 2x to the negative.
2x to the negative.
1. We times it by the reciprocal. But I don't know if that works.
No.
But we got the right answer, but I don't know.
Yeah, it's okay. Hey, listen, 2 points for, listen, 2 points for Sydney. Everybody look at me. Look. You have to be really careful. Anytime you do something wrong, and then you get the right answer, you've got to be more careful because you actually did 2 things wrong. Otherwise, you never could have gotten the right answer. It's not possible. If one thing is wrong, you can't get to the right answer unless you did something else wrong. So just make sure, I'll come look at it, but you've got to be careful. Bell's going to ring. Good job, you guys.
So it's like a double negative.